everybody, I'm Emily Floor. I'm the Education Director for the St. John's Riverkeeper, and I'm here at Jacksonville University at the Marine Science Research Institute. Today we're going to be testing how salty the St. John's River is here. Some of the key terms I'm going to be using are salinity, refraction, brackish, and a new unit of measurement you may never have heard of before called parts per 1,000. My first question to you is, what are the 3 types of water you can find in our St. John's River? Good job if you got all 3. Before we start talking about salinity, we need to define each type of water and where the source is located. Let's start with fresh water. Fresh water does not have any salt in it and makes up most of the St. John's River. We don't advise you to drink it right out of the river, but it will not harm you if you accidentally do. The fresh water in our river comes from rain, which will either run off the land back into the river, or it will seep into the ground through the soil to our Floridan aquifer. We get something very important from our aquifer. Can you guess what it is? That's right, drinking water. Scientists monitor the health of our aquifer by studying the more than 900 springs found throughout the state. 100 of those springs are found within the St. John's River watershed, many of which you can visit and go swimming in. With more and more people moving to Florida, it's more important than ever to monitor the health of our aquifer. So if that is the source of fresh water for our river, where is the source of salt water? The mouth of the St. John's River is located at Mayport, where it meets the Atlantic Ocean. The salt water comes in and out of our river through the tides. The type of water you find in Jacksonville is called brackish water. This is where the salt water from the ocean mixes with the fresh water from the river. It's important to know how much salt is in the water because it determines the species of plants and animals that can live in a habitat. Some species can tolerate changing salt levels and some cannot. Salinity is the saltiness of a body of water and is measured in parts per 1,000 or ppt. To show this visually, the average salinity of the ocean is 35 ppt. If there are 1,000 milliliters of water represented here by 1,000 blue beads, then there would be 35 parts of salt represented by the white beads. The salinity of fresh water is 0 ppt, so you do not see any white beads, and anything in between is considered brackish water. We are going to measure the salinity of a sample of river water using refraction. What is refraction? Refraction is the bending of light through a medium. In this case, the mediums are air and water. Salt water causes light to bend differently than fresh water. You can measure this difference using a salinity refractometer. I'm going to show you how to use this tool, and we're going to measure the salinity here at JU. First, take a water sample. Put it on the refractometer, hold it level, and look in the eyepiece. On the scale inside, you'll see it go from 0 up to 100. We will measure using the scale on the right-hand side. Salinity can change with the seasons and the amount of rain. We took this sample in June and measured it at 21 parts per 1,000. Let's look back at our scale to determine what type of water we have here. Recall that the ocean averages 35 ppt and fresh water is 0 ppt. Based on today's reading, what kind of water do we have here at JU? Right, we have brackish water, as it falls between 0 ppt and 35 ppt. Let's make a hypothesis or educated guess. What do you think is going to happen to the salinity of the river as we move further away from the source of salt water? Is the salinity going to increase or decrease? Be sure to give an explanation for your hypothesis. Let's test your hypothesis. I have a sample collected 15 miles south of Jacksonville University, which is further away from the ocean, and we're going to read the salinity at that location. So I'm reading 5 ppt. Did the salinity increase or decrease as we moved away from the ocean, and was your hypothesis supported? If not, go back and review to figure out why. Now it's your turn. Do the follow-up salinity experiment at home or with your class to investigate how different levels of salinity change how light refracts through water. But don't stop there. Continue your learning by doing additional experiments to compare how refraction of salt water differs from other dissolvable solids such as sugar. And I'm wondering what you'll discover, and I'm excited to hear the results. Thanks for joining me today to study the salinity of our St. Johns River, and we'll see you again on the river soon.